Hello, I'd like to welcome you to a section which will discuss the new Continuing Cal Outliers. Now, there's a lot to discuss with Continuing Cals, typically called CCs. These outliers are designed to measure the continuing calibration sample against the initial calibration curve. And there are several reasons for doing that. First is to automate the continuing cal acceptance criteria. And then the basic purpose of the continuing cal is to check the stability of the calibration curve in a manner that's similar yet quite different than a QC. The continuing calibration game is often played in GC because of the stability of the retention time and the calibration responses. So without going into the background, I'd like to say that typically there's a midpoint calibration concentration that's taken and defined by many EPA methods, and that sample is run, and there are not calibration samples in that particular batch. You use what's called the initial calibration curve, which is the calibration curve that's come from a previous batch. There's often time criteria associated with the time that the samples are run and the time that the CC sample has run. And we have outliers that are set up so that you can do initial calibration verification, or what's often called continuing calibration verification. I'd like to point out that we have detailed definitions of the continuing cal outliers, as you see in the outlier section here. If we go down to the CC part, you'll see the outliers that I'm going to describe and demo for you, including CC response ratio, CC ISTD response ratio, CC average response ratio, CC relative response ratio, CC relative time, and CC time. We'll go over those in a moment. All right, here I am in Batch at a Glance looking at a couple three samples and my CC. What I'm going to do here is get a previous calibration curve from a method from a previous batch. And the easiest way to do that is to go to Method and then open a method from an existing batch. So when I do that, there's a previous batch here, and now I've fetched that method and I've gone over to the method editor, and I'm going to apply that method. Now I'm applying the method, and next I'm going to not analyze the batch, but I'm going to quantitate the batch. Notice that the quantitate batch does not change the calibration curve. This is my initial calibration curve here, and what I need to do is to evaluate this continuing cal sample against the initial calibration curve to see if I've passed the acceptance criteria. And we'll look at how to set that up with the method editor in a moment. All right, here we are in the method editor, and I'd like to point to where you set up the outlier measures. What I'm going to do is go down to the outlier section and where the continuing cals are. So here they are: average response factor, response ratio, ISTD response ratio, relative response factor, and retention time. And I'm just going to show you that if you were to go to response ratio, you can see here are the columns where you would set that up. In this particular case, these limits are very tight, and EPA method would have much greater limits allowed, but these are meant just to trigger the outliers. And for example, retention time, here's where you'd put the window of the allowed CC variance. So without going through each one, I'll show you them demoed in this demo data set so that you can get an idea of what they would look like in Batch at a Glance. Here we are in Batch at a Glance, and let's look at our continuing cal and the outliers. So if we look over here, we can see a list that's been triggered, so let's go through these quickly. The first is, from the time point of view, I'm outside of the time window that's required here for me to run those samples. That's alerting me to that fact. Here's the case where the CC retention time has wandered outside of these, of course, very tight criteria. Here is the CC response ratio, which again has fallen outside of that limits, the ISTD retention time, and last, the ISTD response ratio has fallen out. So this gives you a very good idea of using the CC outlier criteria to help you decide whether you've met the acceptance criteria, and you can go on and run your regular samples without rerunning your cals.